Dear participants, I welcome all of you in this lecture of data processing, pre-processing, where we'll discuss handling of missing values and class imbalance problem. In current week, we'll discuss how to handle missing values. We will also see a class imbalance problem. Then we'll discuss feature scaling, how to scale your features into a common scale. If features are having on different scales, so how can we make our features on a common scale? So that we'll discuss in feature scaling. Similarly, how to let me select the pen first. Then we'll discuss transforming categorical data into numerical values as well. So for that purpose, we are having different type of methods and different mechanisms to convert categorical data into numeric values. Then we'll discuss data discretization as well, where we will actually convert the numerical values into different categories, right? Or you could say in different discrete values, how to convert numeric value into discrete values. Then we'll discuss image pre-processing. So in image pre-processing, we'll see how to perform class imbalance problem as far as image processing pre-processing is concerned. Since using we can create several records, or you could say we can solve class imbalance problem in image processing by rotating the images, and then we'll discuss text pre-processing as well, and finally feature selection. So all these we'll discuss in current week, and all these are actually related to dataset pre-processing. In current lecture, we'll discuss handling missing values, how to handle missing values if suppose in your dataset if certain data are missing. So how to handle those cases. Then we'll discuss class imbalance and its remedies, how to solve class imbalance problem actually. So in most machine learning algorithms, most machine learning algorithm cannot properly work with missing features. Suppose if features are having missing values. So we are having three different options to handle missing values. Missing value, that means, let's say you are having a feature in which certain records are having missing values, let's say null or empty. So how to handle those cases? There are three different options. The very first one is get rid of the corresponding records. So all those records, so we can delete all those records. Let's say in your data set, if you are having thousands of records, and there are certain records which are having missing values. So delete all those records. So it would work for a data set which is having huge number of records. But the data set which is having very low records, or you could say if under some category, it is having very small number of records. And if you are deleting those records, then it would be very I would say this would not be the correct option, right? Since we would miss several potential records. The other way is get rid of the whole attribute, right? The attribute, or you could say the independent variable in which there are certain missing values. Just to delete that column, or you could say variable. Again, this is not a feasible option when your data set is having a few number of features, right? The next one is set the values to some value. I mean, set the missing values to some values. Let's say 0, the mean, the median, etc. So this approach seems to be the most favorable approach, since we are filling the value to some values. Now we can use different functionality like drop in a. So it would drop the certain. It would delete the records where there are certain missing values, where there are certain empty values. So it would delete all those records. This particular method is to drop a particular feature in which there are certain empty records are there. So first we need to identify the feature, and then we can apply this particular method, right? So how to identify the record which the feature which is having missing values, that we will discuss. First we'll get the information of a particular data frame. Then there we can identify the feature which are having missing values. Then this two statement is for filling the value with median value. So first we'll identify the median value of that feature, and then we'll fill the value with the median value. So these are certain approaches of handling missing values. Now I am switching to Google Colab, where I will try to show you how to clean the data. Let me switch to Google Colab. So here I have mounted my Google Drive, and I am reading the housing data set, right? Let me execute this one. So here you can see I have used info method to get the information of this data set. So you can see here there are total 20,640 records are there. I need to identify the feature which are having certain missing values. So longitude feature is having 20,640, latitude is having so one feature, that is total bedroom, it is having records of 20,433. It means there are certain records which are having empty values, right? Or you could say missing values. So this is the potential candidate to handle the missing values, right? So now we will apply three approaches that we discussed. So first we need to utilize. So let me comment out this one. First I will delete the records, right? Delete the records, it means in which the total bedroom is having missing value. So what it will do? It will delete the whole records. So let me apply that one. So the method is dfun.drop na, and then method is subset. Subset is equal to, and the feature is total bedrooms, right? Total bedrooms, right? And then here you need to use in place. In place is equal to true, right? So let me execute this one. Now what happened? It has deleted the record. Now I'm using again, I'm trying to get the information of this data set. So it has deleted those records, right, where total bedrooms are having missing values, right? So that much records have been deleted from the whole data set. So that's why now each data set is having 20,433 records. So it is, not a big deal, or you could say it is not having effect in this case, since this data set is having huge number of records. But let's say a data set is having only 1,000 records or 800, 900 records, and if you are deleting 80, 90 or 100 records, so a good number of records would be deleted in that case, right? So this would not be the good choice where you are having very few records, let's say 1,000 and 2,000 and so on. Now the next option is to drop that feature only, right? So what I will use here, drop. Again, in place, why I used in place? In place, it means this this data frame would be affected. So I want to modify this data frame only. So that's why I have used in place is equal to true. Now the next target is to delete the feature which are having missing values, and that feature is total bedroom. And I need to identify the axis. Axis is, it means I have already discussed the purpose of axis. Axis 0, it means rows, and axis 1 is column. So feature are I'm having are actually the columns, right? So that's why I've used axis equal to 1. Again, in place is equal to 2. So this data frame only would be affected. So now I need to actually re-execute this data frame. Now I'm executing this one. Now you can see here, total bedrooms have been deleted here. You know, that particular column has been deleted, or you could say that particular feature has been deleted here. So this was the second approach. The next approach is to, and the ideal approach is to fill the missing values with mean values, right? So first I need to find out the mean, or you could say median. Let's say mean value. I'm finding the mean value, and mean value of df1 and total underscore bedrooms, and then dot mean. So it would give me the mean value. And before that, I need to re-execute my data set. Why so? Because actually, as of now, this column has been deleted, right? So I need to re-execute, I need to reload this data set into this data frame, so that I can get the that columns. So total, I need to fill the values, missing values in total bedrooms, right? So here I get mean value, then this would be replaced with missing values, fill NA, and here I need to mention mean. So here I need to fill mean, and then which column? So total bedrooms mean, and here all I need to replace. So yes, that's it. So let me execute this one. So sorry, not df1. Yes. Now it has filled the missing value with mean. So that's why you can see here total bedrooms is also having the same number of records. It means the missing values have been replaced with mean value. Similarly, you can use median and maximum value. Let's say minimum value you can replace with mean, median, and so on. So the best option is used to mean value. So this is the mechanism through which we can handle the missing values. Let me switch to the PowerPoint now. So we have seen how to perform, how to handle missing values, and missing value actually come under data cleaning strategy. Now the next task that we'll see is a class imbalance problem. So class imbalance occurs when the observation belonging to one class in our data set far outnumber the observation of the other classes. Let's say a particular category is having very high number of records. Let's say you are having there is a data set that is having binary classification type of problem. So I mean the dependent variable is having only two values, either it is 0 or 1, and suppose records related to 0 is having a large number of records actually, and the 1 is having very less number of records. So that is the case of class imbalance. So it means one class is having so much number of records as compared to other class. So this disparity can cause models to become biased towards the majority class and leading to inaccurate predictions for the minority class, which is often the class of greater interest. And why there is the minority classes are having greater interest? So it is very crucial to the cases such as fraud detection or rare disease identification. So the minority class may be the most important one for prediction. And failing to correctly identify instances of the minority class can lead to significant consequences. So for that purpose, we need to handle class imbalance problem as well. And there are several techniques to mitigate class imbalance problem. And Python library provides several modules to implement these methods. And the very first one is resampling techniques, which actually oversample the minority class. It means, let's say, zero class is having very less records. So it would oversample the minority class. And for that purpose, we'll use IMB learn package, and then here you need to use random over sampler, right? So random over sampler. So we are trying to oversampling the minority class. So this is the way we can apply oversampling of minority class. Again, the random state is equal to 42. It means it actually guarantees that you can regenerate the same records, right? So this is the very first option, resampling. And the another one is undersampling. It means you undersampling the majority class, right? So suppose one is having large number of records as compared to zero class. So one class would be undersampled, right? So in this case, we'll be using IMB learn dot undersampling, and here we'll import random undersampler, right? And the rest step would remain same as random oversampler, right? So in this way, we can use this undersampling. Next technique is SMOT, which is very popular technique, and it is also called, it is actually called the synthetic minority oversampling technique, which is commonly known as SMOT. Focuses on augmenting the minority class by creating synthetic instances. So it will actually, SMOT will create synthetic records, or you could say instances. It operates by oversampling the minority class, whereby it generates new synthetic examples or records rather than simply duplicating existing ones. So it is actually not duplicating the existing instances, or you could say records. It actually generates the new one on the basis of methods, how one records is related to another record, identify the relationship between different records. So in this way, it actually create the new instances. Let me switch to the Google Colab, where we will discuss class imbalance problem. Here I am trying to read diabetes dataset. Let me execute this one. So, and you can see here, actually, I have grouped this dataset on the basis of outcome, and you can see the outcomes. This particular feature. Let me show you first the whole dataset. Here I am trying to print df, the data frame, right? So, sorry, df dot info. Yes. So you can see here in diabetes dataset, it is having 768 records. There is no any missing values, and there is one outcome which is actually having zeros and ones, right? Only 0 and 1. And here I am trying to group the data set based on outcomes. So to get to know the instances under ones and instances under zeros. So, sorry, uncomment it and let me execute this one. So, you can see here 0 is having 500 records and 1 is having 268 records. So, 0 is oversampled and 1 is undersampled, right? Now, let me execute, I will first try to implement random undersampler. So, what a random undersampler will do? Just think on it, what we had discussed. So, it would actually, delete the records of the class which are having most number of instances. So, since 0 is having more number of instances, you can see here, right? So, it would undersample it. It means it would delete the record so that 0 class would also be would also have 268 records, right? So that 1 and 0 would have similar number of records, that is 268. So, first I have import this random undersampler and then I am creating an object of that and a new x and y. So, what is x here? X is actually the independent features and this is the outcome, y is outcome, right? So, in this way it would generate new x and y. Sorry, it is not having. Okay. So, first I need to create x and y as well, right? Let me execute this one. Yes. So, now I have got these values. It has undersampled my data set. Let me execute this one. Sorry. Let me print x underscore res dot info. Sorry. So, I am printing here print and then x underscore res dot info. And then let me execute this one. So, total is 536. It has reduced the instances. Previously, the instances were 7. What we had seen, it was having 768 instances. Now there are 536 instances. It means it has deleted certain records under zeros, right? Now I want to see how many values are there, how many instances are there related to zeros class and ones class. So, I would use a loop here. So, for I comma j in and a in y underscore res dot iter rows, so that I would read all the records here, and if j dot values is equal to 0, then I will make it here k0 is equal to k0 plus 1, else k1 is equal to k1 plus 1, and I would mention here k0 is equal to 0 and k1 is equal to 0. I want to know the total number of records related to 1 and zeros as well. So, here I have counted the total value related to 0 class and 1 class. Print k1 dot k0, right? Let me print this one. So, you can see here 269 and then 268. It has given me this record 269. Sorry, no, this should be 0, right? That's why it is coming as 269. No, it should be same, right? So 268, 268. So it has reduced the, this random undersampler has reduced the data. Now I would use oversampler. So first I would change here. I would change here oversampling and random. Over sampler, and here I need to apply over sampler and then x and y, right? Let me execute this one. Over sampling random, this is over sampler, yeah. So now it has oversampled it. Let me execute this one again so that I can count the value. Yes. So you can see here. Now against 0 class it is 500, and for one class related to ones it is having 500 records. So now it has oversampled. The value the records, or you could say instances related to one class has been oversampled. So in this way you can apply oversampling and undersampling, right? So this was related to the problem of class imbalance and how to handle. Similarly, you can apply smooth test as well. Now I am summarizing here. So we had seen how to handle missing values, or you could say filling missing values. Then we discussed class imbalance problem and its remedies. It means we had seen several techniques: oversampling, undersampling technique, and then smooth as well. So utilizing all these methods, we can handle a class imbalance problem as well. So thank you so much for joining this class. We'll meet again in our next lecture.